All right, next we're going to do different types of bonds. Again, this isn't a physics or chemistry class, but we will get into these bonds later on, so it's important to have a good understanding of some terms we'll use with them. So ionic bonds. This is where you have donation and acceptance of electrons. So for example, NaCl, what this really is, this is a bond between two ions. So I had a sodium ion that gave up an electron. Remember, electrons are negative here. So since I lost an electron from this sodium atom, it's losing an electron, making it positive. This chlorine atom is gaining an electron, making it negative. These are now ions, and they can make an ionic bond. So the charges are going to depend on valence electrons. So let me get my valence picture up. Here for sodium, sodium has, here's this, in its valence shell, sorry, I'm looking for my tool. There it is. So in its valence shell, it has one. Come on. It has one electron. Okay. Since it has its one electron, but it's in its outer shell, we said that outer shell is now full. So this is neutral. When we take this one electron, let me see if I use that number really quick. Sorry guys, I don't want to talk too much chemistry if I don't have to. Okay, so in this valence shell, to get to this noble gas configuration, you need 1, 2, 3, 4, 5, 6, 7, 8. So you need 8 electrons in your outer shell to be in this noble gas configuration. When you look at sodium, just basic sodium, it has all these different rings, and these rings, all these inside rings, have 8 valence electrons. Now that it has, even though it's neutral here, since it has this 1 valence electron, it's considered not stable. So the easiest way to get to this full valence shell, this noble gas configuration, is to lose 1 electron. Once it loses 1 electron, then it has this charge, and it can make an ionic bond. So the whole idea, you have this gaining and losing, or this donation and acceptance of electrons that are going to create ions that carry charges that allow these things to create ionic bonds. That sodium, this positive charge, makes this a cation. And the way that you remember that, this cat, this T, looks like a lot like that positive symbol. So cations are positive, and these negative ions are called anions. Okay, the next kind of bond that we'll talk about is covalent. These are when atoms share electrons. So instead of completely losing one or another, they share them. This is the most common type of bond in the human body. They're more stable than those formed in ionic bonding. And we can get into polar versus nonpolar. This is basically just differences in nonpolar. I don't want to get too much into chemistry, but this has to do with differences in electronegativities, which is an attraction to electrons. If any of that doesn't make sense, you can do a little bit, like just a Wikipedia search of covalent bonds should help you if you need a little bit more reminding from your chemistry class. But anyway, so we have these are all in our body, and they can be polar or nonpolar. It has to do with the electrons spending time in the nucleus, like I said, the attraction to the electrons. Polar means the electrons are spend their time way more on one element versus another. So if you look at H2O, for example, this is a polar molecule because oxygen light is so much more electronegative. It means that the electrons are going to chill over here for the most part. Since they're chilling over here, these electrons are negative, so this will be more negative than this. It's not a complete. We do a little symbol like that to show partial. But the whole point is, since the electrons are hanging out over by the oxygen way more than they are these hydrogen, this is a polar covalent bond. versus if you had an oxygen and an oxygen, these guys are going to share their electrons equally, right? And so that would be a non-polar covalent bond. Hydrogen bond. Hydrogen bonds are super important in our body. They hold our DNA strands together. They're an attractive force, so the different things that you really look for are oxygen, nitrogen, and fluorine. These can make hydrogen bonds. So here's my H2O, and here's another H2O. I can have this attraction between these different molecules, because remember we had that partial negative and that partial positive. These also partial positives. This has to do with how the electrons are spending their time. Well, since I've done that, now I can, since we have this partial negative, oh, that's not what I wanted. Since we have this partial negative and partial positive, we can get this attraction, which is called hydrogen bonding. But this only takes place between a hydrogen and then these types of atoms.